All right, so in Chapter 8, Section 2, we're still dealing with distributions, but instead of dealing with the sample mean, we are dealing with proportions. So sampling distribution still, but dealing with proportions. And so very similar to the last section, the mean of our p-hat, our sample proportion, is the population proportion. But the standard deviation of the sampling distribution of p-hat, so this thing is the square root of p times 1 minus p over n. And so this is something that we'll have to calculate when we're dealing with proportions and we're looking to find probabilities or proportions, percentages of populations. So let's look at an example. And there are some criteria. One is that n times p times 1 minus p has to be greater than or equal to 10. If that doesn't occur, we can assume that it has a normal distribution, that it's approximately normal. And also we're looking for less than 5% of the population. Our sample needs to be less than 5% of the population. If we have more than 5%, then maybe we're asking people over again, or it just wouldn't have this normal bell-shaped look. So n times p times 1 minus p has to be greater than or equal to 10, and we're looking for sampling less than 5% of our population. So on a problem like this, we see that sample size is 75 of a population that's 15,000. So we can easily see that 75 divided by 15,000, that is less than 5% of our population. So we are good on that end. We have to check if n times p times 1 minus p is less than 10, or greater than or equal to 10, sorry. Greater than or equal to 10. And so we check that by our sample size is 75, p, the population proportion is 0.6, and we multiply that times 1 minus 0.6, so I could write in 0.4, but I'll just type it all in. I want to get 18, so that's greater than or equal to 10, so looks like we are good to go. So the sampling distribution, we can say it's approximately normal because of these two conditions. Our sample size is less than 5% of the population, and n times p times 1 minus p is greater than or equal to 10. Fantastic. And the next part, again, that the definition says that the mean of p-hat is equal to the population proportion. So we can just say the mean of p-hat is 0.6. So that's an easy one. Next is going to ask us to find our standard deviation of our p-hat. Again, how much our numbers vary. Formula, again, square root of p times 1 minus p over n. And so on my calculator, I can do square root of 0.6 times, again, 1 minus p, or 0.4. And that's divided by n. Our sample size was 75. So to 4 decimal places, I get 0.0566. Oh, 6 decimal places, even better. 0.056569. So we got 6 decimal places. So we'll make sure that we use that number in a minute. So now we're looking at the probability, right? Obtaining x equals 51 or more with the above characteristics. Now, they got 0.68. So where did this 0.68 come from? Well, to figure out a p-hat is x over n. So if I'm looking at 51 out of the 75, that would determine my p-hat. So that's where this 0.68 is coming from. When we're looking at finding the probability of this happening, that's when we're going to go to StatCrunch. We're going to open up our normal calculator because we've said it's approximately normal because it meets these conditions. And we have our mean of p hat, which was 0.6, and we have this 6 decimal standard deviation of p hat that we calculated. So calculators, approximately normal, so we're going to the normal calculator. Our p is 0.6, and our standard deviation is, oh, I lost it. I'll find it again. 0.6 times 0.4 divided by 75, so the square root of all that. So 0.0565 0.0565 69, and it was greater than 0.68, so 51 out of 75 is that 0.68. So now we can see that probability, the area to the right, is 0.0787. So awesome. We got one part remaining, and in this part, it's asking for a different one. So 36. So 36 out of the 75, which again would give us that 0.48. 36 out of the 75, so that's where that number is coming from, right? And they want to find out the probability that's less than that. So again, just go back to StatCrunch. We're dealing with 0.48 versus the 0.68 this time, and it's less than to find that probability. So both section 8.1 and 8.2 are dealing with distributions. We're looking at sample mean distribution and a sample proportion distribution. For us to be able to use the normal for proportions, again, n times p times 1 minus p has to be greater than or equal to 10, and the sample size has to be less than 5% of your population. And then we can go to our normal calculator and compute things once we find the mean, which is the easy part, and then calculate the standard deviation for